Hey guys, this is me Ajit and this is the second video of my machine learning course. And as I told you in the last video that in this video we're going to talk about Python's random library and we'll see that how we can use it with NumPy. So first I'm going to open my Jupyter notebook. So Python actually comes with built-in random library and there are tons of functions included in this library. So first of all we have to understand that how we can import the random library. So simply we can write import random, or what if we want to import a particular function from random library. For doing that we can simply write from random import any function which we want to import. Now if we hit the tab button, we'll get all the functions which are available or which comes with the random library. And here we can see that there are n number of functions which comes with the random library. But we are not going to talk about all the functions of random library. We are only going to talk about the important ones. So the first function which we are going to talk about is random itself, and what it simply does is it returns any random floating point number between 0 and 1, and here it doesn't need any parameter to be passed. Like I'm showing this with an example like random dot random, and here we can see that it returns a floating point number between 0 and 1. We can try it again, and here we can see that the output here is a different number because it is generating a random floating point number. Now the second function in the random library is the shuffle function, and first we will see that what this shuffle function does. So it randomly shuffles around any sort of list. So let's create a list. Like I'm creating a list named my list 7, and now I'm using the shuffle function here, and I'm passing the list as a parameter. And now when we will check our list, we'll find that our list is shuffled, and if we run that shuffle function again, we'll find that our list is shuffled again. Now the third function which we are going to see is randint. Now what randint do is it simply allows us to grab a random integer, and now I'm showing you the syntax of randint, and here we have to pass two parameters where the first one is the lower and the second one is upper, and the lower one is inclusive and the upper one is exclusive. Now I'll show you this with an example like random dot randint 1 to 10. Now what it will simply do that it will give us any random integer between 1 and 9. Why 1 and 9? Because the upper parameter is exclusive, that is why it is not included. Now I'm using randint again, 1 to 10. And here we can see that we get 9 here because it is generating random number every time. Now there is a function which is similar to randint and it is known as randrange, but it is somehow different than randint. And now we are going to see that how randrange is different from randint. So randint accepts 3 parameters. The first one is lower, or we can say it start. The second one is stop, and the third one is step. Like when we can use randint, like suppose we want any random even number, like we don't want odd numbers. In that case we can use randint. Or like we want multiples of 5 or multiples of 3. In that case we can use randrange. Sorry, it's randrange. Now I'll show you this with an example. Random dot rand range 200 and step size is 2. So here we can see that we get 92 as an output, and I'm going to run it again. Random dot rand range 200, step size is 2, and here we can see that we get 24. So what we are going to get here is 2, 4, 6, 8, 10. That we can only get even numbers here because we have mentioned the step size as 2. And if we put the step now if we put the starting parameter as 1, we can simply see that we are going to get all the random odd numbers between 1 and 100. And here also the stop parameter is exclusive. That is why 100 is not included. Now the third function which we are going to talk about is choice. And in the choice function we can pass list as a parameter. And what does this choice function do is it return a random element from the given sequence, and the sequence must be non-empty. If the sequence will be empty, then it will produce an empty index error. Now I'm showing you this with an example. I'm passing a list. Okay, and here we can see that we get our output as a random element from the list. I'm running that again, and here we can see that we get 6 here. I'm running that again, we get 4 here. And what if we pass an empty list as a parameter? And what I've told you earlier, that if we pass an empty list as a parameter, then we'll get an index error. And this is what we get here, an index error. Now we will see that how we can use the random library to create arrays in NumPy. So first I will import NumPy. Now many of you will think that why I'm importing NumPy as NP. Well, you can use any abbreviation other than NP, but as most of people are using NP as the abbreviation, so it is better to use NP. Why? Because all the programs which you are going to find on the internet and everywhere, you will find that they are importing NumPy as NP. So it is better to develop a habit of using NP as the abbreviation rather than using other abbreviations. So now np.random.rand. And what this rand function does, that this is gonna create an array of given shape we pass, and it's gonna populate it with random samples from a uniform distribution over 0 to 1. So if I want a 1D array, a one-dimensional array, I'll pass the parameter as a single digit, like I'll pass 4, and here we can see that I find an array having 4 elements. Now what if we want a multi-dimensional array? So for 2D array, instead of passing tuple as a parameter, as we have seen that in the other functions which we are using with NumPy, we pass tuples as parameters to create multi-dimensional arrays. But here we are not going to pass tuple as a parameter for creating multi-dimensional array. What we are going to do is that we will simply pass the integers separately. I'm showing you this, np.random.rand 4, 4, and here we can see that we got a 2D array of 4 by 4, and there's another function which is similar to rand, and that function is random, and we use it when we want to return a sample or many samples from the standard normal distribution or a Gaussian distribution. Instead of using rand, then we use random. Like I'm showing you this with an example, np.random.randn, and I'll simply pass 4 as the parameter, and this will return numbers not from uniform distribution from 0 to 1, but instead from a standard normal distribution centered around 0. And here we can see that we got negative floating point numbers too, which shows that we got elements which are standard normal distribution centered around 0. Well, we can also create multi-dimensional array by using this random function in the same way we have done by using the rand function, like np.random.rand and 5 by 5, and here we'll get a 5 by 5 matrix which is randomly distributed over 0. Now we can also create an array by using the random function. So we are going to see that how we can create arrays by using the random function. So I'm going to write np.random.rand int 1 to 100. In this case, we are going to get a single element, which is an integer. So how we can generate an array from this random function? But one thing which we have to keep in mind, that 1 is inclusive and 100 is exclusive, which means that we can get 1 as an output, but we cannot get 100 as an output because 100 is exclusive. And if we want a particular number of random integers, then we can pass the size as well, like np.random.rand int start, stop, and the size. And here we can see that we get 10 random elements. But this is a 1D array. What if we want to create multi-dimensional array by using this random function? So, well, we have a function for that too, and that function is known as the reshape function. Now I'm going to show you that how we can use the reshape function. So like np.random.random 1 to 100, 1 to 100, 25. So this is going to give us an array of 25 random elements, and now I'm going to convert it into a 5 by 5 matrix. So So I'll simply use the reshape method and pass 5 and 5 as parameter, and here we can see that we get a 5 by 5 matrix of random integers. Well, we can use the reshape method with all the built-in methods which we have talked earlier about. Like I'm showing this by using this reshape function with arange method, like np.arange 1 to 26 and reshape 5 by 5. And here we can see that instead of getting a 1D array of first 25 natural numbers, we get a 5 by 5 matrix. But by using the reshape method, we have to keep one thing in mind, that we will get an error if we can't fill up the matrix. Like I'm showing you this with an example, np.arange 1 to 20. Okay, and I'm passing 5 rows and 5 columns, and this is producing an error. And why it is producing an error? Because for a 5 by 5 matrix, there should be 25 elements in the matrix. Now, but the arange method here will produce 19 elements only. But for this reshape method to work, we need 25 elements. Now, what I can simply do is, instead of using 5 rows and 5 columns, I can use 5 rows and 4 columns. And here we can see that the reshape method is now not producing an error because this arange method has produced 20 elements. And this 5 by 4 matrix also requires 20 elements only. That is why this reshape method here is not producing any kind of error. Well, what I think, that learning anything without practical knowledge or without relating it with the real world scenario is quite boring. And for making it interesting, we have to keep on discovering new ideas by which we can implement what we have learned in our daily life experience. Like I'm going to show you that how we can use this random library to create a lottery system. Well, we all know that how a lottery system works. Like we are going to get a lottery, and if our lottery number matches the lucky lottery coupon number, then we are going to get a prize. So how we can create a lottery system by using random library, I'm going to show you that. So first, print welcome to the lottery system /n. Let's try your luck. Now I'm going to ask user an input of his lottery number, given, and I'm naming the variable as lottery, and I'm typecasting it as int input enter your lottery number. And now we are asking the Python's random library to generate a random lottery number. So random dot rand int, well, I'm taking 1 to 10, and if luck is equals to lottery print congratulations, you win. Else, friend, better luck next time. Now I'm going to run this program, and here we can see that it is asking for my lottery number, and I'm typing my lottery number as 5. And here I can see that I lose, and it is saying better luck next time. Now if we want to see that which number wins the lottery, for that we can simply do is print lottery number that wins dot format luck. And here I'm entering 5 again, and you can see that I'm not that much lucky because I lose again, and the lottery number that wins is 1. So in this way you can also create many small programs like this. Like you can create a Ludo, because in the game of Ludo, when we throw a dice, we are getting a random number. So by using the random library, we can create a Ludo game too. Well, I had created a Ludo game when I had learned this random library, and if you want me to share that Ludo game with you, then let me know in the comment section. And that's all for this video. Thank you.